two. Yeah?
You wanted me to re-ask my question. Are you ready for it?
Yes.
What is the difference between the average of the population and the average of data?
Good. I want you to hold that question because I'm going to back out and then come back in again. Yes, that's a huge part of today. It's kind of central to today. So thank you, Allie. Good. We were in Math 244. Here's a big overview, and we're going to get back into what we got into with the penny spins last time. Math 244 essentially is two huge topics. We're going to spend about 4 weeks in this class doing what's called estimating parameters. This ties into Allie's question. What is a parameter in statistics? I know parameters has lots of meaning. The word parameter has lots of meanings in the world. What does the word parameter mean? What do you remember from parameter from 243? Good. This is actually a very good image.
It's the outlier, the definition of the sample, the outline.
What does outline mean? I like that.
It's not like a range of values.
It's a range of values that you're estimating from where? If you're a statistician, or if you're a researcher, or if you're a psychologist, or if you're a sociologist, you're interested in something in your population, right? You're interested in something in your population. You're interested in an average. Suppose you think you've developed some kind of a rehabilitation method for a shoulder injury amongst snowboarders who have Terry's minor pulls. I'm just making this up because that's what I have right now, except I'm doing it right in blank. So you've got a new rehabilitation method you want to check out, and you want to see if it works. You want to estimate how much recovery is happening via your method, right? The parameter would be whatever that increase or decrease in recovery time is. The problem is you're never going to know what that is because you have to actually go out and survey and measure and test every single injured person with a Terry's minor pull. But you can't do that, right? So you draw a sample. You draw a sample and you test that. Well, if you're only basing it off a sample, whether it's a percentage or an average or whatever it is, are you going to be 100% precise with that? No, we learned that in 243, correct? So what do we slap on that measure? A plus or minus, love that Tyler, plus or minus a margin of error, which is what we're going to start talking about today. So the first thing you're going to do is estimate the parameter. I want to get back into that after we talk about this overview today. The second thing is something called hypothesis testing. Hypothesis testing. Which, honestly, there is quite a bit of interplay between these two things. Some statisticians argue they're exactly the same thing said two different ways, potato, potato. You'll see why when we get to that. That's going to be about week 4-ish, 4.5-ish, 3.5-ish, somewhere in there. This is what we're going to start with, though, today. This is what we're starting with today. So, I want to come back into where we were on Thursday of last week. I had you guys spin a bunch of pennies. We're going to leave the cards for right now. You'll look at the quiz again. It's a fun quiz to get in there with the Monte Carlo. We'll come back to the cards because the cards are a little bit more applicable here. Because the reason hypothesis testing is a slight bit different than estimating parameters is in hypothesis testing, you make a claim and then you test that claim. Your hypothesis is a claim. And you guys had a good hypothesis that day. Your cards suck! That was a good claim, right? It was a good claim. I made you formalize it. What does it mean my cards suck? What does it mean the card's not fair? Too many black cards. Not enough red cards. Good claims. You're going to test that claim. What a parameter estimation would be is, can we estimate what percentage of the deck is actually red based off that sample? Now we could. We could, although the sample was so small, it's going to be a noisy estimate. Like, for example, you might say, I'm fairly confident there are between 0 and 100% red cards in that deck. Well, that's fair assessment, fair, not very accurate, definitely not very precise, but it does track what we're looking for. And that's what today is all about, is can we estimate this? Can we estimate that based on a sample size of this? Yeah, Allie, go ahead.
Do we use a t-test for any of that, or is that...
We will. T-test falls into hypothesis testing. A t-interval will fall into estimating parameters. So the t-distribution